Hello, welcome. Today we are going to be looking at the production of X-rays. How are X-rays produced? We're going to be looking at the working principle of an X-ray tube. Now, in the previous classes, we learned that electrons can be made to move out of the surface of a metal by number one, thermo or thermionic emission, or by number two, photoelectric emission. When the movement of the electrons is caused by heat, it is called thermionic emission, as it is written here. But when it is caused by incident light ray, it is called photoelectric emission. Today we are going to be looking at one of the applications of the one caused by heat, and that is production of X-rays via thermionic emission. Now, an X-ray tube consists of a filament F, which is the cathode, from which electrons are emitted by thermionic emission, and a tungsten T, which is the anode, that is the side that is receiving the electrons, embedded in a copper block. Both are enclosed in a partially or totally discharged tube at low pressure. When a high voltage is provided across the electrodes, the required heat necessary for accelerating the electron is obtained. The accelerated electrons, on hitting the target, which is actually the anode, generate heat at that point. This heat is cooled by cooling fins or by circulating water or oil around a hollow target. So the basic setup of an X-ray tube is actually a big tube that has one side as the filament cathode and the other side as the tungsten target anode. So because inside this tube it is discharged, there is very low pressure inside it. So this low pressure will enable the free movement of electrons from the cathode, which is the filament, to the tungsten target. So there has to be voltage generated across the electrodes to enable this movement. Now we look at the types of X-rays. There are two major types of X-rays, the hard X-ray and the soft X-ray, and this classification is based on their penetrating power. That is the power of the X-ray to penetrate your skin and get to your bone. So if the intensity is high, it has high penetration power and it is called hard X-ray. And this hard X-ray is produced at a voltage above 20 kilovolts, whereas the one that has low penetrating power, produced at a voltage lower than 20 kilovolts, is known as soft X-ray. Now, what are the uses of X-ray? This X-ray that we are producing, what are we going to use it for? Number one, it enables the shadow of bones to be cast on a screen, thereby making it possible to detect fractured bones or arm joints. When you get to the hospital, you have a fracture and you want your bone to be seen so that you can know how to go about treating them, you go for X-ray. When you want to check your heart, to see your lungs, to see whether you have problems around your heart region, you go for X-ray, because it is only X-ray that can penetrate your skin and see your bones so that it can be either examined or be printed out. So the X-ray enables the shadow of the bones to be cast on a string, thereby making it possible to detect fractured bones or arm joints. Number two use of X-ray is to treat cancer. By taking the advantage of the ray intensity for hard x-rays. You can use it to burn cancer cells off. So two major uses of x-rays in checking our bones for fracture or for checking the inside of our body, dictating what is inside. And number two is for treating cancer. Because of the intensity of the ray, you can use it to burn cancer cells off. Please, if you like this video, click the subscribe button below by this side. If you have any questions concerning these and other lectures that we are bringing to you, please drop it on the comment section down. If you want to contact us so that you can help us or support us in any way or call us for help, please check the description part of this video. Thank you so much. God bless you.